Welcome everyone, and thank you so much for being here today. My name is Peter. I'm a Senior Director at Systemic. We are a mission-driven B Corp that focuses on systems change advisory. So rather than just a single corporate, we would look at an entire system and how to transition systems to a sustainable model of operation. You can see on the screen now the 5 platforms that we have and where we operate, particularly, I guess, in this instance, looking at the energy and the material circularity platforms, where I sit between. So that's where we as an organization are focused. Go to the next slide, please. Great, thank you. So Systemic has been modeling the plastic system extensively and quantitatively for the last 5 years, in collaboration with several people in the room today as well. Most notably, I would call out Reshaping Plastics on this slide, which was a study in 2021 focused on what maximum circularity in the European plastic system can look like if we apply all of the circularity levers available to us today, as well as fossil-free plastic and biogenic feedstocks as well to get to net zero and carbon capture. Furthermore, Planet Positive Chemicals down the bottom there is also a global net zero scope 1 to 3 transition study of the global chemical system too. So that has been used to inform the SBTi's chemical sector guidance, for example. So it's building upon 4 years worth of understanding of the plastics system and modeling that quantitatively that has brought us to today and this report. So just very briefly, where are we right now? The system is fossil-based, predominantly linear, and at end of life, we predominantly incinerate plastic, which means that we have a very highly emissions-intensive system today to the tune of 5 tons of CO2 emissions per ton of plastic used in the European system. So this is not a sustainable model of operation today and highly GHG intensive. What do we do about this? Well, there are 4 major levers, groups of things that we can do to get the system to net zero and potentially beyond net zero. Firstly, circularity. Circularity is key to drive a resource-efficient system, make the system as manageable in size as possible to abate. After that, what are we making the plastic out of? Fossil-based feedstocks ultimately are going to be contributing to the amount of carbon we have above ground, and therefore switching to fossil-free feedstocks, renewable sources of carbon, can fundamentally shift the amount of GHG intensity by not contributing further carbon to the overall economy. After that, we can then use renewable energy sources in the production and the value chain of plastic. And then lastly, we can use carbon management, so carbon capture and storage for any residual greenhouse gas emissions that we have from production and from end of life. So these are the 4 major lever groupings that can be used to get the system to net zero. And fossil-free feedstocks are a critical lever that is an integral part of getting the system to net zero. So the system today will scale. We will see increasing value and use of plastic in the system. And without circularity, we would scale to a system of 69 million tons. By efficiency reduction measures, so upstream circularity measures such as reuse, elimination, substitution, we can keep the plastic system efficient. We'll still need roughly the same amount of plastic as we use today to support a much bigger system that will then be much more efficient. However, of that 54 million tons that we will still need in 2050 of plastic, actual physical plastic, even if we scale circularity to the absolute maximum that we can, then we'll still require around 28 million tons of virgin plastic. So about half of the plastic can come from circular measures such as recycling, and then half of the plastic will still need to be virgin plastic. whether from fossil or fossil-free. Now, this diagram will take a little moment to get. Essentially, we need to get our carbon from somewhere, whether it's from the ground or the air, which is on the vertical axis here. And long term, after we've used that carbon as efficiently as possible, we'll need to dispose of it, either into the air as emissions or into the ground through permanent sequestration, whether that be landfill or carbon capture and storage on incinerators. So there is a long-term pathway for this carbon. Today we're on the bottom left of this diagram. We dig our carbon out of the ground, we typically use it once, and then at the end of life we burn it, which means we're driving 5 tons of emissions per ton of plastic, as I've said. Now, what we need to do is to switch to any one of these other 3 boxes. We can source our carbon from the air, use it, and then burn it at end of life, which is the top left here. We could arguably dig the fossil out of the ground, make it into plastic, and then at end of life, we sequester it. We put it back in the ground. The trouble with that pathway is that even if we do have an abated fossil system, we still drive 1 ton of emissions per ton of plastic used. So it will still continue to drive climate change, even if we abate the fossil system with the ground-to-ground model. What we really need to target is the top right model in the dark blue, where we take carbon from the atmosphere, use it as efficiently as possible in a circular system, but then dispose of it in the ground at end of life, whether that is through landfilling or carbon capture and storage on incinerators. What that can do is have a really transformative effect on carbon flows. So rather than have the 5 tons of emissions going from the ground to the air, it can drive up to negative 2.4 tons of emissions going from the air to the ground. So you can reverse the flow of carbon by between 5 and 7 tons per ton of plastic production. And in doing so, actually remove carbon permanently from the atmosphere. So this is the trickiest slide in the deck, so please bear with me. These are the 3 scenarios that we've modeled. The left scenario here is an unabated, scaled system without circularity. The middle one is without circularity, but we max out fossil-free. And the third one, the integrated scenario, is where we have a combination of all these levers. We abate the fossil system, we drive circularity, and also we introduce fossil-free plastics. The integrated scenario gets you to net zero. The integrated scenario makes the most resource-efficient use of very scarce, available, sustainable biomass today, and also energy efficiency. The max fossil-free scenario offers a very positive GHG benefit, right? So the system can actually even get beyond net zero. Ultimately though, given the scarcity of resources and sustainable biomass that's highly competed from other sectors, there is an absolutely imperative need for circularity to get to a resource efficient system and also get there in the most de-risked way, so that the spectrum of possible emissions in the event, for example, that carbon capture and storage fails to scale on fossil, can be avoided, that there is a risk of significant GHGs. So ultimately, an integrated scenario that combines circularity, fossil-free plastics, and also abated fossil system during production and at end of life is the best scenario to end up in. So this is a slide on cost of production. The cost of fossil-free plastics will come down over time due to cost reduction measures at scale. I think the target of this slide is to really think about how fossil production, when abated, can be compared like for like with fossil-free production at scale. So what we see here is as fossil-free plastic scales, the cost will potentially decrease to a level of parity with abated fossil production. So what we see is around between 1,700 to 2,200 per tonne on the fossil-free side, and then 1,900 to 2,000 per tonne on the abated fossil side, when we're thinking about the abatement of that fossil system and the fully valuing the carbon that is emitted from these things. So what we see is a degree of economic parity that is achieved when at scale. I would stress that this is for olefins and this is pure cost. So we know now that we can have a regenerative climate impact and a very beneficial GHG impact through the scaling of fossil-free. We know also that economic parity can very reasonably be achieved. But beyond that, there are strategic benefits of fossil-free plastic. Firstly, it's offering a drop-in virgin quality product and also segregated production. So there's no mass balance challenges. It's a completely separate production pathway, therefore making it easier for off-takers to clearly account for the GHG benefits of investing into fossil-free plastics. Secondly, the scaling of fossil-free plastics scales up the net zero production value chain. So whether that is from renewable energy, green hydrogen production, green methanol scaling, and also from the management of high integrity sustainable biomass, this can lead to a thriving EU chemical sector that is leading on tech innovation and de-risking the industry transition as well. And then lastly, there are sectoral synergies from that upstream value chain for other sectors to transition, whether it is in the shipping space or whether it is in other hard-to-abate sectors. There are halo effects and synergies that can be achieved to support the transition of the broader EU economy. And lastly, in doing so, this can support EU leadership in the clean industrial transition, so that we are remaining competitive on a world stage as other regions scale. So this is the last slide. What do we need to do to scale fossil-free plastics? Well, at the moment, industry is already investing. As we know, Vionio is already targeting the launch of their plant in Antwerp, and it's critical to get these first proof of concepts at commercial scale over the line to demonstrate that it can be done and how it can be done, and create that initial value chain for fossil-free plastics. So mobilizing the strategic customers that see the value of this pathway is critical to begin establishing the nascent market. But beyond that, we then need to start thinking about how we really scale up fossil-free plastics beyond one plant to 10 plants, then one day to up to 100 plants. So to do that, firstly, a bold industrial strategy can provide the market signals that then will allow the industry value chain to be proactive and begin to move, seeing the fact that this is the direction of travel and that this is a critical part of the future of the plastic system, will enable the investors and the industry players to begin to move early, rather than waiting for policy. Thereafter, clear market foundations are required to build market confidence. This comes from both the definition of fossil-free plastics and inclusion in policy, but also the accounting methodologies that can then fairly value fossil-free plastics. For example, the -1+1 system that can then really recognize the carbon negative potential of fossil-free plastics to create a true value of that pathway. And then lastly, structural market support. Now this is really critical. Firstly, we need to stimulate demand. Ultimately, the first part of the S-curve is the hardest part to pass through, so therefore really moving on the first offtake volumes and driving those into the value chain is critical to get the market starting to scale up. Also creating a level playing field by helping the European system fully value its plastic and protecting it both from an international export perspective and also looking at the true value of the carbon at end of life, for example, the incinerator base and the inclusion in the ETS. And then lastly, structural market support. So various different market intervention mechanisms where there are market failures, for example, the green market makers applied by H2 Global and various other market instruments can be used to overcome some market failures around the business case. So in the medium term, for the scale up of the market, some of those market interventions can be used to get multiple plants to FID and therefore create this as a new norm for the plastic system. So I will stop there. That is the conclusion of our report and the key recommendations for what's required to scale fossil-free plastics. I hope that was informative and has answered as many questions as it's proposed, but I'm very keen now to hand back over and we can get some reactions to the report. Thank you so much.